Hello everyone, welcome to Real Tutors Online platform. We say thank you to all of our subscribers, and if you have not subscribed or if this is your first time on this channel, I would like you to click on the subscription button so that you can get notifications whenever we post new videos. Also, if you find this lesson informative, I would like you to click on the like button. We also expect your comments so that we can get feedback from you. Today, I want to continue working on prime factors. I will advise you to go and check our previous videos where we started prime factors. We're able to show how to find prime factors of numbers. If you have not seen the videos, you can check the description. You will see the link there. You can click on it and then you watch the video. Okay, so today I want to continue on prime factors, and I'll be working basically on the particular theorem that we call fundamental theorem of arithmetic, which states that a number is either prime or can be expressed as a product of its prime factors. So let us start. I will do a little reminder of how to get your prime factors. For example, if you want to get prime factor of 24, what you have to do is you need to first list out the factors. There is a video that I already taught us on how to get factors of numbers. So you need to first list out the factors and then you get out the prime ones. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So we list out which of them are prime. 2 is prime, 3 is prime. So the prime factors of 24, they are 2 and 3. Just the two of them. So we have this in mind, and then we want to now find a way that we can find 24. We can get 24 by having the product of these numbers. So what you need to do is just to draw a table. You have 24 here, and you have at the back of your mind that you can only divide by 2 or you divide by 3. So you come to 24. Let's start with 2. You write 2. When you divide it by 2, you have 12. Since you can still divide 12 by 2, you continue to use 2. So the point is you have to use a number until you can no more divide it by it. So you have 12, then you can use another 2 to have 6. Since you can still divide 6 by 2, you have 2, you have 3. Now 3 is not divisible by 2. We already talked about divisibility in one of our previous videos. If you have not seen it, you can also check for it so that you understand what I'm saying clearly. So 3 is not divisible by 2. So we go to the second prime factor, which is 3. So you use 3. The moment you get 1, you stop. Anytime you get 1, you stop. And then you write it out that 24 is equal to 2. You take the numbers one after the other. 2 multiplied by 2, multiplied by 2, multiplied by 3. Okay? 2 multiplied by 2, multiplied by 2, multiplied by 3. To beautify it, sometimes you may have to write them in index form. Index form is when you are dealing with multiplication, how many of them are, how many 2 do we have there? 1, 2, 3. So that's going to give us 2 raised to power 3 multiplied by 3. So by this, we've expressed 24 as a product of its prime factors. So that's basically what we have done, expressing 24 as a product of its prime factor. If you compute this calculation, if you do 2 times 2 times 2 times 3, you will definitely get back 24. So 24 is not a prime number, but it can be expressed as a product of its prime factors, which obeys the fundamental theorem of arithmetic. So I'm going to do another example. This time I want to go to 3-digit number. I want to talk about 120. 120. You want to list out the factors of 120. You have them. 1 is a factor. You have 2. You have 3. You have 4. You have 5. You have 6. You have 8. You have 10. And then you have 12. 12 is also a factor. You have 15. You have 20. You have 24. You have 30. And then you have 60. Then you have 120 itself. But you need to now write out which of them are prime. Which of them are prime. And then I think we still have 40. There is an omission. We still have 40. After 30, we have 40. We have 60. We have 120. Okay. So we check which of them are prime. Don't forget, in our previous video, we already established the fact that prime numbers are numbers that have just 2 factors, 1 and themselves. So you have 2 is a prime number, 3 is a prime number, 5 is a prime number. So what we did for this is the same thing we are doing. We want to list out the prime numbers to know what we are going to divide with. So you have prime factors of 120, you have them as 2, 3, and 5. So whenever you want to find the multiplication, the product that is going to give us the number, all we have to do is to be dividing by the prime factors. Okay, so let's go. Start by drawing your table. You have 120, and then when you divide by, as I told you that I will start from the first one, then the moment you cannot divide by it again, you go to the next one, then to the next one. Okay, so when you divide by 2, you have 60. 60 is still divisible by 2. You can see that in divisibility rule. So you go ahead to divide by 2 again, you have 30. 30 is still divisible by 2. So you go ahead to divide by 2 again, you have 15. But 15 is no more divisible by 2. Then we check which one is the next number, 3. So you go ahead to 3. Can 3 divide 15? Yes, 3 can divide 15 perfectly with no remainder. So you go and then you use 3, so you have 5. Then 5 is not divisible by 3, so you go to the next one, which is 5. So you have 5, and then you have 1. So you can now say that I want to express 120 as the product of its prime factor. It's going to occur as 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5. So I told you to beautify it. Sometimes you can write in index form. And what do I mean? You pack the ones that are common together. So how many 2's we have there? We have 1, 2, and we have 3. So that's going to be 2 raised to power 3 multiplied by 3 multiplied by 5. Okay, 2 raised to power 3 multiplied by 3 multiplied by 5. If you compute these products, you get back your 120. Okay, so if you think you understand, I want you to lay your hands on one. I'm going to be giving you one question and I want you to do it. Then the moment I write the question, I will also write the answer. But to be able to check if you are always correct, I want you to do it, pause the video, then solve it. After you've solved it, then play it so that you can see the answer to see if you are correct. Okay? So let's go. So I would like you to find, to express, I would like you to express 180 as a product of its prime factors. I want you to express 180 as a product of its prime factors. So pause the video now, solve it on your book, and then play it back to see the answer. Okay, so welcome back. Since you've played it, you've solved it now, you should see that your answer is equal to 2 raised to power 2 multiplied by 3 raised to power 2 multiplied by 5. So if they are correct, I will say congratulations. If you still make some mistake, you can watch the video all over again, understand it, and then come and solve it. Thank you very much. See you next time.